Okay, so on to the last video for homework 22, exponential modeling. So the drug Valium is eliminated from the bloodstream exponentially with a half-life of 36 hours. Suppose that a patient receives an initial dose of 90 milligrams of Valium at midnight. How much Valium is in the patient's blood at noon on the first day? Okay, so how much Valium is in the person's blood on the first day? Recall this equation, transition over. So this is the equation we'll want to utilize. The amount found, well, that's how much Valium is in the patient's bloodstream at noon on the next day. That's what we're going to find. The amount at the start multiplied by the 1/2 raised to t over time for the half-life. So let's go ahead and write this out. Q is Q naught. Q is for quantity, by the way, if you're curious. Or I assume it's for quantity. It makes sense. Okay. All right. So what do we know? We know we have a half-life of 36 hours. Okay. I know I'm looking at noon on the first day. So T is 12, T sub H is 36. Q naught, how much do I get? Initial dose of 90 milligrams. All right, cool. So Q, the amount found at noon on the next day, is going to be the 90. Milligrams. So this 90 is being measured in milligrams. That's the initial dose. Then the dose at the start, 90 milligrams, multiplied by 1/2 raised to the t. Well, t, that's the time you're going to look. And noon on the first day, we took it at midnight, so t is going to be 12 hours. T sub h, well, that's the half-life time. That's 36. So if I take 90 and I multiply it by 1/2 raised to the 12 over 36, well, 12 over 36, that's 1/3 if you're curious. 71.433. This 90 was measured in milligrams, so this result is being measured in milligrams. There is approximately round to the nearest tenth, so rounding to the nearest tenth would give me 71.4. Got it. Estimate the Valium concentration. Estimate when the Valium concentration will reach 5% of its initial level. So recognize when they're giving us something in this style, the 5% of its initial level, recognize what they're telling us with that 5% is Q over Q naught. Which equals 0.05. And well, if Q over Q naught is 5%, Q, the amount you see, the amount you find, Q naught is the amount from at the start, that's 5%. Well, if we take this equation and we divide by Q naught on each side, we see that this must equal 1/2 T over T sub H. So I'm taking this equation. I know T sub H, that's still my half-life, and I'm solving for T. After approximately blank hours, the Valium concentration will reach 5%. So I'm solving for the amount of time that has to pass to reach 5% of the original dose. So as you might anticipate, I need to free up this exponent, so I need to implement a log. So we'll take a log of both sides. we go. And then yet again, I can take this exponent and bring it out front and write it as a multiplicative factor. And then divide by log of a half. So I see log of 0.05 over log of a half is equal to t over t sub h, and then yet again multiply by th to completely isolate t. So recognize th, well that's our half-life, 36 hours. So I'm going to take 36, and I'm going to multiply it by log 0.05 divided by log of a half. 155.589. So 155.589 approximately, round to the nearest hour, so 156 hours. The volume concentration will be 5%. Nailed it. All right. Suppose that poaching reduces the population of an endangered animal by 2% per year. Furthermore, suppose that when the population of this animal falls below 20, its extinction is inevitable. Okay, if the current population of the animal is 1,500, when will it face extinction? Comment on the validity of this exponential model. Okay. So suppose poaching reduces population of the endangered 2% each year. Okay. Furthermore, suppose that when the population falls below 20, its extinction is inevitable. If the current population of the animals, when will it face extinction? Okay. It's 1,500, and we're going to remove 2% each year.